My name is Dominick, and I spent the last 20 years of my life basically helping software companies build authentication and authorization into their applications. And, we went through several technology iterations, right? I started with Kerberos, and then there was this WS Federation and SAML and SOAP era, right? WS Security. And then, I guess after that, came a new era where newer protocols took over, simpler protocols, I would also say, and basically it's all around, today, around OAuth and OpenID Connect. And that already is 10 years ago, I think. Yeah, OAuth was, I think, released in 2011 or 2010 or something like this. And it pretty much became the de facto standard for anything we do when it comes to, securing APIs, for example. So I built a couple of token services along the way. So I read these specs more than once, which is, very exciting. And, for the last 10 years, OAuth was, the base specification of OAuth, remains unchanged because that's how RFCs work. You cannot change an RFC anymore. But there were things added on top of it to cater for all kinds of scenarios that no one thought about, right? When they started with OAuth in the first place. I mean, OAuth, to be honest, was built to solve a very simple scenario, right? Like, how can you give a third party access to your Gmail inbox without having to expose the password to the third party, right? That was the whole problem statement by the time. And they came up with this thing called OAuth to solve exactly that problem. And if you look today, OAuth is used everywhere. It's if it's like just normal business stuff up to banking and healthcare and, very sensitive systems. So people's, the IETF started adding more and more specs on top of that for higher security scenarios, and to enable things that, were not easily possible in the first place. So someone counted all of the pages of all of the specs from the OAuth working group, and it's double the size of War and Peace, right? And now you can decide what's more exciting to read. And if you've been to my talks in the past, I probably drilled into specific features or advanced stuff or whatever, right? But 2022, I think, will be a turning point because for the very first time, the OAuth people, so to speak, look back and think about removing stuff from the specification because 10 years later, it proved not to be the best idea. It looked good by the time, but didn't stand the test of time, okay? And so I thought, why not, revisit OAuth, the basics, and tell you in 60 minutes what I think, if you are working with OAuth, these are the things you should know about, okay? And it actually fits in 60 minutes. Yeah, I mean, I'm not saying you will be an OAuth expert after that, but definitely these are the things that you want to know about or even learn about. And the other things are not relevant anymore and are pretty much a distraction today if you're reading the original OAuth spec because these things are not used anymore, okay? Right, so that's kind of the idea of this talk. It's a completely introduction talk, right? So if you know OAuth already, you'll be disappointed, because you will not learn anything new. But if you want to relearn OAuth because you thought, that was too complicated or I didn't care, then you're in the right place. If you have never used OAuth before, you are in the right place. So this is a beginner's talk, okay? I don't want to hear any comments after that saying like, oh, that was too basic. Yeah, that is the idea behind it, okay? Cool. So, if you want to contact me, here are my contact details. Also, there's a speakerdeck.com account where I uploaded the slides already. Yeah, so if you want to have those slides, you can just get them from there. I put all my conference talk slides there, so if you want to go back in time, that's also possible. Cool. So, to give you some history, this is kind of the short history of web-based authentication. Yeah, so it all started in 2005 with a protocol called SAML 2P, which was the very first attempt to do web-based single sign-on. It was, and again, and that's coming up a lot here in this talk. Always think of back in the time, what was the prevalent technology, and they invented something to solve the problems of the existing stuff. And the existing stuff in 2005 was Active Directory, right, and Kerberos and these kind of things, which only worked on the intranet. So people wanted to have something which works on the internet, yeah. And SAML was the first, protocol that was created. XML-based, of course, because that was the thing to do by the time. And then WS Federation, WS Trust are, derived specs from that for, web, what do they call them? XML web services by the time, right? And things like that. OAuth 1.0 came out in 2007, and that was exactly what I just said, to solve this very specific problem, how to grant a third-party access to your data without having to expose your password. And then OAuth 1.0 became very, very popular. That 5 years later, they created a new OAuth, which enabled even more scenarios. Yeah, like they thought about mobile apps and JavaScript-based applications and other things. And also more and more companies got involved in that, and they wanted to simplify the whole thing. So that's what OAuth 2.0 is. Yeah, and from that point on, as you can see, a whole bunch of specifications have been added, and this is not even a complete list. Yeah, so if you want to have the more friendly version of that slide, that's how the IETF website looks like. So you can read through all of them. Yeah, but my main point is that you see here on the soon, maybe here or here, I don't know. There's this thing called OAuth 2.1. Okay, and that is basically the next iteration of OAuth, which think of it as a reverse semantic versioning. Like in semantic versioning, you're only allowed to add stuff to it and don't break existing stuff. They do exactly the opposite, yeah? They remove stuff from it, and, break existing scenarios is the wrong word. They also don't use the word we remove it, they only omit it, which is a very important distinction. So that's where we are. So, and, it kind of feels like, it's time, if you would learn OAuth today from scratch, you probably wouldn't want to go back to the original specification. You would want to read the new one, 2.1, which is not done yet, but I have high hopes it will be done next year. And while this new spec is not thinner than the old one, it omits the things that you probably don't care about anymore. Yeah? But and once you know the good parts, maybe you want to learn the bad parts as well, just to understand why they are bad, but that's not our topic for today. Cool. So my agenda is, first of all, tell you why does OAuth exist. Yeah. Then we're going to talk about this thing called protocol flows, and there were a couple of those in the past. We have slimmed it down to only 2 that you really care about these days, and then we're going to look at typical application architectures, and that's, again, a very, very short, brief intro to that. And then we're going to have a look at OpenID Connect, and why does it exist, and why is it often, why people use OAuth and OpenID Connect in the same sentence. Again, don't expect too much details here, it's one slide. Okay? And then I'm going to point you to some further reading resources. Cool. So, why does OAuth exist? Yeah, again, think of the times, right? 2007, 2000, whatever. That these were the heydays of XML, right? XML web services, WCF and whatever it was called in Java. No one really loved that technology, right? I mean, did anyone love, really, like, deep in your heart, I love XML web services? Not really, right? They were heavy-handed, they were complicated, it was really, really hard, yeah? And all we want to do is invoke some APIs on the internet, right? Why do I have to become like have a PhD in angle brackets for that? But one interesting technology fell out of the whole XML era, which was token-based authentication. Okay, so instead of sending around names and passwords all the time, they created these things called tokens, yeah, which represent access to a resource without having the credential inside of this data structure, so to speak, right? And that token by the time was, of course, XML-based. Yeah, it was called a SAML assertion, yeah, or SAML tokens in the Microsoft space, as they call it. And you can see there's pretty much, there is a lot of information in there, right? And the majority of the information you see on that slide is to make XML happy, right? It's not actually data that we are transporting metadata of the data, yeah, something like that. But there were some interesting concepts here, right? For example, the concept of an issuer. Who has issued the token? Do you trust that issuer? And if you trust the issuer, then you, by transitively, allow access to a resource. To enforce that trust, there are signatures involved, right? So I can validate the signature. I can make sure it's coming from the trusted issuer. There were things like time windows, right? This token was not valid forever or as long as your password. It was maybe just for 1 hour or 1 day or whatever, right? There was the idea of scoping, that this token is not useful at all of the APIs. You can only use it with specific APIs, right? So you can scope down the access of that token. There were information about authentication. Maybe your API did care how the user did authenticate, yeah? Like with a password in this example. And of course, they had claims, meaning you were able to transport additional information about the caller and about the user in that data structure. So these were all good concepts, but no one liked it. Yeah? It was too much ceremony, so to speak. Yeah? And the real problem was that OAuth was all about interoperability. Right? XML, you kind of made XML work inside your own company, right? But try to find 2 XML parsers from 2 different companies that actually like each other, right? That produce the same result, and then you throw signatures on top of it and all the other stuff. It was not really easy to do, you know, like interop with other companies, other technology stacks, and so on and so forth, right? So the whole thing did not really take off in the age of, you know, the internet and consumer services and so on, right? So people thought like, okay, let's have something simpler, yeah, something that is not XML, yeah, which doesn't make it simpler necessarily, but still, it's not XML. We are done with XML, kind of, yeah. So they, you know, introduced this thing called OAuth. So let me walk you through the bits and pieces that make up an OAuth-based architecture. So the idea was pretty simple. You have an API, right? And they call it the resource in OAuth, yeah? And this API, you want to allow access to this API to some callers, right? Now, reusing the concept of tokens, they basically introduced something called the Authorization server. And that is a piece of software that can produce tokens that allow you to call the API, okay? The authorization server, by definition, always belongs to the same entity where the APIs belong to, right? Because the format of the token was unspecified by the time. The contents of the token was unspecified by the time. So it was really always, the token is an implementation detail between the issuer of the token and the consumer of the token, which is the API. That's why, you know, even today, you know, authorization servers belong to a certain entity. You bring them up to secure access to your resources, okay? Or APIs, whatever you want to call them. And then on the caller side, we have what they call clients. So client is a piece of software that wants to call your API, right? And there are 2 fundamental types of clients. We call them public and confidential clients. So public clients are easy, right? They are things like running in a browser or on a phone, whatever, right? They are basically clients that you would never ever base a security decision on because they are not in your control, okay? But still, these use cases exist, of course, and we need to enable them. And confidential clients are basically, typically, things running on a server, yeah? To put it in easy words, the OAuth spec says a confidential client is a client that can securely store a secret. Yeah, so that typically means it's some process running on infrastructure that you control, typically on a server, and hopefully you are storing that secret securely. Okay. Now, the next thing the next term you need to learn is called resource owner. And I really don't like this term. And typically these days, people talk more about users. Yeah? So a user basically is a carbon-based life form, in your system, right, that wants to use your services, yeah? And the user is using a client, which is a piece of software, to access your services. No? And then whatever flow you're doing in OAuth, it will always boil down to these fundamental steps. The client makes a call to the authorization server to ask for a token. Yeah? If it's a confidential client, the client will authenticate to the authorization server as well and say like, hey, give me access to the API. Yeah? And if that is successful, the authorization server will return the access token, and then the client will use the access token to call the API. Okay? So it's an abstraction. The API doesn't really know anything about the client or the user, not necessarily at least. But as long as the token is coming from our trusted authorization server, I'm okay. Yeah? So that's the whole architecture. Now, you might have more than one API, right? So here they only talk about one single resource server, but in reality you have many APIs, yeah? And a very, very important concept in OAuth is, you don't want to grant access to all APIs to all clients. Yeah, you need some way to maybe say like, okay, client 1 can call API 1 and client 2 can call API 2, and the client needs to express that somehow, right? And that is called the scope parameter. That's a very, very important concept and is heavily underspecified in the OAuth spec. Yeah, so if you look at like whenever I show you something with a Korea font, it's official, right? So they basically say something like the scope specifies the scope of access. It's a string, it's space delimited. Typically the assumption is the longer the string, the more things you want to access. And the order doesn't matter, of course. And then in the true OAuth spirit, yeah, they say like the authorization server may fully or partially ignore the parameter. Yeah? Because by the time they weren't really sure what the use cases will be. But very, very typically these days is you have APIs, you give them names, right? And then the client will use that name to say like, hey, give me access to your calendar API or to your invoicing API or whatever, right? And these names are defined by you. Here's an example. If you go to the developer documentation from GitHub, that's how they structure their scopes. Yeah? It's a certain philosophy here, right? They see GitHub as one big API surface, and then you have, if you want to have access to repos, you ask for the repo scope. If you want to have access to users, you ask for the user scope. If you want to have access to the packages, you ask for the package scope, right? Sometimes you need to be even more specific, right? You see here they have something like write package, read package, delete package, and so on, right? Because, maybe it makes sense to say, I have this automated CI process. It should be allowed to publish a package to my repo, but it should not be able to delete them, for example, yeah? So that's why they introduced this more fine-grained things. But the OAuth spec says it's just a string, right? It's totally up to you how that string looks like, yeah? And they won't help you with anything of that. As a different example, that's how Google structures their scope surface, right? So Google is a much, much bigger company, right? You can imagine that maybe at GitHub, every GitHub employee meets at the Christmas party or something, right? They know each other, so it's a bit more a casual environment, I guess, yeah? Whereas Google is like a really, really big company, right? And probably the Gmail API developer never met the calendar API developer and so on. So you can imagine they have something like a registry in Google, right? There's one person that is the master of the scope names, so to speak. And when you want to bring up an API, you probably tell them, hey, there's a new API. He probably will assign you basically like a prefix, right? They're using URLs here, so they probably give you a URL prefix, and then the developers probably can decide, okay, let's call it Gmail compose and Gmail read and whatever, right? Again, it's just a string from an OAuth point of view, but this is a different style, I guess, more an enterprisey style, I guess, yeah? Okay, cool. So that's the fundamentals, done. You already know 20% of OAuth. Now, let's look at two fundamental ways how you interact with an OAuth-based system. Yeah? And that's what I meant earlier. There have been more ways in the past, but we are basically condensing it to two fundamental ways to interact with the system. And that's good, because you have less to learn. Yeah? So the first protocol flow we want to look at is called client credentials flow, and it's optimized for classic machine-to-machine style communication, right? You have one, like a batch process, wants to call an API. How can it call the API? How can it get tokens? And so on. There are no users involved here, only machines, okay? And that's the simplest flow. Let's going to start with this, and then we make it more complicated. So the way this works is pretty simple. The client opens a connection to the authorization server and sends an HTTP post to the so-called token endpoint. And the spec says the post body must contain a thing called CRAN type. It must be client credentials, and then you pass in the scope, right? The thing that the client wants to access, API 1 in this case. Yeah, the client must authenticate. In this case, we're using an authorization header for that. And then the authorization server, and that's where the name comes from actually, is now checking, is the client authorized to call this API, right? And if yes, it's going to send us back a JSON document. And in this JSON document, you will have two things. One is the actual access token, yeah, and the scope that was granted, and the expires in means how long will this access token be valid for. Okay, so in this example, the client is now able to call API 1 for 1 hour, and then he has to start over and get a new token. Yeah? How does an access token look like? Well, the OAuth spec itself does not say anything about this. Actually, the OAuth spec predates JSON Web Tokens by 5 years or so. Yeah. So just in the last 5 years, it became very convenient to package up access tokens in a JSON format because JSON is everywhere. You have libraries for that. It's not that hard to use and so on. And you can see basically a JSON Web Token has two parts: a header, which has some metadata like the signing algorithm and which key was used to sign it, and then the payload has the actual data, like where is the token coming from. That's issuer. Issued at was when was the token issued. Expiration is how long will the token be valid for. Scope is the API that was granted access to, so that the receiver can check that. And client ID is who is the caller, right? And guess what? It's all the same, right? It's the same concepts, but not with angle brackets. It's JSON now. Yeah? It looks nicer, I agree, right? But the ideas are the same. There are issuers, there are signatures, there's a time window, there is scoping, and there are claims. Okay? Cool. So, how do we use the token now? There is only one legal way in the future to use an access token, and that is, well, two, but yeah. To basically put it on a special header in the HTTP call, the authorization header is that's called. The reason why this is special is because it typically is not locked on web servers, right? The browsers know that it contains sensitive data, so it has a special treatment, so to speak, in HTTP. Then you put the string bearer there. Bearer comes from the OAuth spec. It must be there to tell the recipient that what they're going to expect here is an OAuth token. Okay? So if you want to see this in code, if that's easier, basically let's imagine that's my simple client here. You see that there's always a two-step process here. First, I request the token. That returns me an access token, and then I'm going to call an API, right? And calling, requesting a token, there are client libraries for that and so on. But basically here you see I'm requesting a token. I pass in the token endpoint address. I pass in my client ID, my client secret, and the scope of access, right? And if that's all successful, this returns me a token. And then here I'm putting the token that came back on the authorization header, and I'm calling the API. That's how it works. Yeah? Good. So, there are some access token processing rules. I don't want to bore you with all the details, but one thing is really, really important. Namely, from a client's point of view, the token is opaque, right? Even if the client knows, oh, it's a JSON Web Token, I could read it myself and look what's inside, you are not allowed to do that, right? I said earlier, the token format and the token contents and the token semantics even are a private implementation detail between the issuer and the consumer. The issuer can at any point in time change the token format as long as the APIs know how to pass it. right? But if the clients take a dependency on token structure, you're going to break all your clients. Well, it's the client's fault in this case, to be honest, because they were not allowed to peek into it. But I'm just saying that because I've seen so many implementations in my life where people are actually doing that because it was the pragmatic thing to do. Yeah? Yeah? So from a client's point of view, it receives an opaque blob of data from the token server and forwards that blob of data to the API, and that's all they are doing. Okay? Cool. And then there are some other things that, don't care too much right now. I mean, we could, but it's about signature validation and blah, blah, blah. It's not really that important. You typically have libraries, like in ASP.NET Core, that there's the Dominick Baier authentication handler, which does all of the heavy lifting for you. So, one other thing to understand is that from an OAuth point of view, there are two very important status codes in HTTP. One is 401 and one is 403. And they have very different meanings. So the 401 status code means you are trying to access a resource. This resource requires authentication, but you are failing to show the right credential, right? The token is missing, the token is invalid, and for most of the times, what that means is your token has expired, right? So you have a token, 60 minutes are over, you send it, the server will say, no, that's not good, 401, which probably means, the recommendation here is if you get a 401 from an API call, it is very useful to get a new token and resend the API call because it might work. Yeah? The other status code is called 403, and that is forbidden. And what that means is that you have a perfectly valid token, but what you are trying to do is not allowed. Yeah? So basically some authorization rule that you are not fulfilling, which means at this point, getting a new token and resending it will not solve the problem, right? I mean, when you are unauthorized, logging in again to the same website won't make you authorized. Yeah, it's the same idea. So distinguish between the two, especially when you're writing a client, right? Because 401 means I can do something about it. 403 means, well, you ultimately have to show the user something like, I don't know, access denied. I don't know, yeah? Something like this. Contact the administrator. Right, and then the last step, once you have the token, is token management, right? So you don't want to request a token for every API call. They are valid for a certain time window, so cache the token, keep it around, use it, and only when you have to get a new token, that can be done proactively by using a cache lifetime that is shorter than the token lifetime, or what you're ultimately going to end up with is do it lazily, right? Like just use the token until you get a 401 and then renew it and resend the call. Yeah, that is, in my mind, the best, resilient implementation. Okay, cool. So that's easy. I mean, it's not hard. So let's move on to interactive applications, where it gets a little bit more complicated because now you're not having to only coordinate machines, you also have to coordinate humans. Yeah? Which is harder, always. So there is the mother of all flows, if you like, in OAuth. It's called the authorization code flow, and that is exactly designed for situations where you have a human being, a user, using some interactive application, like a web application, and this application wants to call APIs on behalf of that user sitting in front of the computer, right? It is designed for allowing UI workflows, right? So login pages and maybe other things that you need to do. And it also gives you a way to manage the token lifetime without having to involve the user. Yeah? Think of, like after 60 minutes, you don't want to log in the user again and again and again. There must be some way to make this better from a UX point of view, and that's called refresh tokens. Everybody heard of that, I'm sure, before. Good. How does the authorization code workflow work? And that is often where people are confused because it's a little bit more involved. But ultimately, to be able to both cater for the human being in front of the machine and the machine itself that needs the token, we need to break up the flow into two steps. And one is called the front channel step, and that's always a browser being involved here, right? Browsers are great. You just give them some URL, they show some UI, perfect. Yeah? That's also the biggest vulnerability, by the way. But but it allows us to show a UI workflow, right? Like a login page, as I said, or other things. And then once that UI workflow is done, then the client application opens a second channel, which we call the back channel, to actually harvest the results of that UI workflow. So you might now question, why don't we do that in one single round trip? Well, because access tokens are actually sensitive data, and we don't want to transmit them via the browser, right? Via the user's computer, which we don't trust, right? We don't trust the browser, but basically, what you want to do is you want to only transmit the sensitive data on the back channel, right? Server to server, basically. Cool. So let's have a more detailed look at that. So how does the front channel request look like? Well, it's basically a redirect to the so-called authorized endpoint. You pass in your client ID, right? So you are registered with the token system. You pass in a redirect URI, and that tells the server where to go back to once the front channel is done. Yeah. You pass in the response type code. That's just what OAuth says you have to do. And you pass in the scope of access, right? Again, this application wants to call API 1. Yeah? There are more parameters here, which are not really important for our discussion, but there's an extra spec called proof key for code exchange, or PKC, that you have to use today. This did not exist when OAuth 2.0 was created, but in OAuth 2.1 it's mandatory, and it means you have to add this additional parameter here called code challenge, which is basically just a hash of a random number, which is a secret for you for this one request. As I said, we don't have to go into details here. So that is the front channel request. And now, basically, the authorization server takes over and can show an arbitrary workflow, right? So it probably will want to authenticate the user if that is required, or maybe there is already an existing single sign-on session. And how that works is an implementation detail of the authorization server, right? They could support names and passwords or whatever other authentication system, right? Google, Azure AD, I don't know, whatever, right? And after the authentication is done, there's another step which is optional from a protocol point of view called consent. And I'm sure you've all seen consent screens before in your life, right? When you connect your mail client to Google, they ask you, like, do you want to expose your mails to this mail client or in Facebook, wherever, right? So the whole idea of the consent screen is to involve the human being to make an informed decision, right? And that's why they pack typically a lot of information on that consent screen. Yeah, like, this is me, right? I'm the authorization server. We think you are Bob. Yeah, we think this application is called MVC code flow, right? And then what is this application asking for? Yeah, and in our case for API 1 access. And then ultimately, the user can click the yes button or the no button. I mean, has anyone ever clicked the no button? Sometimes you should, yeah. I recently had a weird one. I can't remember where it was. Basically, but they asked for a lot of access to my GitHub repos just for, I don't know, just for doing a commit. This consent screen, as I said, is optional. Many companies have this first-party versus third-party split, where they say, like, if the client application comes from us, we don't have to show this screen. We already have your data, right? What's the point of asking you again? But if the application is a third-party application accessing a system, you might want to have that. Also GDPR, there are some rules here as well. Like if you register your app with Google, they will always show this screen for the very first time, but Gmail does not show it, for example. Yeah, enterprise scenarios typically don't use it either, right? And so on. But it does exist, and it is useful for certain flows. Okay, cool. So now the user has clicked yes, and now what the authorization server will do is basically go to the redirect URI that was configured on their side and transmit a so-called code. Okay, that's this parameter here, and that's why it's called the authorization code flow. That is basically the artifact that gets returned to the client, and what that basically is, it's a random number, right, that points to a record in a database at the authorization server, which has basically all the information that happened during the authentication and authorization process. Yeah? But on its own, it's not very useful. Yeah? It's just a random number. Now, what the client must do now is take this random number and open the back channel now. Okay, so we are done with the front channel. We're going to do the back channel now, and then we're going to send this code that we just received on the front channel to the back channel. Now, this call is, again, authenticated. Yeah? Has some other extra parameters here, but basically only if you are the client, yeah, that did the front channel, you will be able to get the data on the back channel as well. There are all kinds of checks in there, you know, client authentication is involved, and so on. And then ultimately, what this code exchange will produce is, again, our access token response. Okay? So it is pretty, you know, you're getting the same thing back as with the client credential flow, but it's a two-step process, again, to protect exactly that data from the browser. Okay? If you are doing access tokens in user-centric scenarios, you will often find additional claims. Yeah? So for example, in this scenario here, all of the claims are the same as we saw before, but now we also have a user ID, right? The SUB claim is the subject ID, so that the API knows, oh, this is not only a machine, there is a user on behalf, the client acts on behalf of a certain user to access the API. Yeah? And that is, of course, very important for authorization purposes, right? So imagine a Twitter client, right? You grant the right to timeline scope to the client, but still, the client should only be allowed to write to the timeline of the currently logged on user, right? And that's why the API needs to know who is the user, and that is part of this OAuth flow. AMR is another one that you might see. Stands for Authentication Method Reference, and that tells the API how did the user authenticate at the authorization server. Yeah? So maybe some APIs require multi-factor authentication or smart cards or whatever. So that's a way that this API could check this. Yeah? And again, if you want to see some code, it's not easy to show because this is typically wrapped up in client libraries. Yeah? But if you're using, for example, ASP.NET Core, yeah, they have this thing called the OpenID Connect authentication handler. And you see basically, you just configure this. You say, here's my token server, here's my client ID, here's my client secret. I want to use this code response type. And these are the things I want to access. Here's my API 1. And so on, right? And then basically, this library from Microsoft then takes care of both the front and the back channel, which is quite nice, yeah? All of these nitty-gritty implementation details don't really matter to you, yeah? Okay. Now, one thing that Microsoft unfortunately does not implement, and that's something you still have to do or use libraries for that, is token management, right? They only take care of the initial token request. Once the token is in your application, you know, you can use it, but it will have a finite lifetime. Yeah, again, think of it like, let's say 60 minutes, okay? But what if your front-end application allows an 8-hour session, for example, right? Or even sliding expiration or something like this. After 1 hour, the token will not be good anymore, and you need a new token. Yeah? And that is absolutely good because you want to keep token lifetimes as short as possible, right? If you are leaking them somehow, you want to give the potential attacker a very small time window to mount the attack. So don't make access tokens live for hours or days or weeks or whatever, right? I mean, I have seen all these things already. So to get a new token, right? It would be a very bad user experience if we would now send the user back to the authorization server, right? So imagine you're in the middle of typing something and suddenly the browser makes the redirect and comes back, and that would not be really nice, yeah? So there is a way to do that programmatically, without having to involve the user, which is called a refresh token, which is very similar to a sliding expiration cookie, just that you implement the sliding logic yourself because the browser isn't doing it for you. So how do we refresh an access token? So imagine now our application is running. After 60 minutes, we call the API. The API returns a 401. We know, okay, maybe the token has expired. So what you do then is you get this refresh token from wherever you store it, yeah, in a database or in your session, and then send this to the token server programmatically on the back channel, right? Re-authenticate with the token server, and then you will get back a new access token. Okay? And this new access token will be valid again, in this case, for 1 hour, right? And then after 1 hour, you repeat that, you repeat that, you repeat that, until the application is done, right? Some applications do background processing, so they store the refresh token in a database, for example, right? To do whatever they need to do without you even being present, right? You might be long gone, shut down the computer, but some server is working for you. Yeah? The nice thing about refresh tokens is that they give us an okay way to get given a client application long-lived access to an API without compromising security too much, because the refresh token can be revoked. Okay, so some companies provide you with a self-service style revocation page, right? That's Google in this case. They don't use the word refresh token here, right? These are apps connected to your account, right? But if I press the remove button here, what they will technically do is delete the refresh token from the database, and once the access token has expired, the next time the client wants a new access token, that will fail, and you have to send the user again through this interactive workflow before they can do that, right? So maybe you gave some application access to your data, and after a week you realize, nah, I don't want to use this application anymore, so let's revoke the access to it. Yeah? That's an end user thing. For developers, I can totally recommend to do revocation whenever you need to. There's a revocation endpoint specification, RFC 709, which specifies an endpoint at the authorization server where the client can say, okay, I have this refresh token here, I don't need it anymore, please invalidate it for me. So it cannot be used anymore, right? That's a really good idea. So if you only need the refresh token for the duration of your interactive session, when the user signs out from your application, just revoke it, right? These days it's so much harder to delete data than create data, but that's your chance to delete some data. Yeah. And of course, right, you can't leak it anymore. If someone finds it in old log files or old database, whatever, they will be gone. They will not be useful anymore. Okay. So that's basically, these are the two flows, yeah, that you need to know for machine-to-machine client credentials. For anything else, really, it's authorization code flow. And now let's have a brief look at common, scenarios where you want to apply these flows. We don't have to talk about machine-to-machine anymore. I guess that is pretty obvious, right, how that works. But for interactive applications, I mean, if you really think about it, there are only two types of interactive apps, right? The ones in the browser and the ones outside the browser. That's really it these days, yeah? So if you're building a browser-based application, and that might be, classic MVC style, or sparse, or the new hotness like WebAssembly stuff, then you are always going to use this authorization code flow. And a typical technology stack looks like this, right? You have an application server. On that application server, you have an OpenID Connect or OAuth client library, like the one I just showed you from Microsoft. Then you have some session management to deal with the user session, to being able to do the authorization flow, start a session afterwards, and when you're done, stop that session, get rid of the tokens. Then you typically have a token management library. That's the thing that is keeping your tokens fresh, right? And then ultimately, you have some UI assets, right? And it really doesn't matter anymore these days if that is JavaScript or server-side, whatever. That's pretty much how it looks like, okay? If you're not in the browser, then you need a browser. Yeah, not for your application, but for triggering the authorization workflow, right? So I'd love to say it's a very common approach for native apps to use the browser to authenticate you. But as we all know, this is not the case, right? Many native apps still bring up their own native login dialogues and implement it by hand and so on. That's not recommended really, right? The whole idea of OAuth is that the client can never see the credentials of the user, right? So by putting up your own login pages, you are kind of bringing this ad absurdum, right? So the recommended way of doing this is that your native app basically opens the browser temporarily, yeah, forwards the user to the authorized endpoint. The user does his UI workflow, and then the browser comes back, transmits the authorization code back to the native app, and then the native app turns the code into tokens. Yeah? This has many, many, many advantages. First of all, you are leveraging probably what you already have on the browser, UI, logging, auditing, workflows, federation with other providers. All of these things just work, right? You don't have to re-implement them. Modern operating systems have specialized browsers for exactly this that are only used, for authentication sessions. Right? So on iOS, for example, there's this thing called AS Web Authentication Session, I think they call it. It's a special browser. It is the system browser on your iOS device inside the client application. It is hardened that the client cannot lock the keystrokes, for example, inside that browser. You have full access to your password manager, to your certificate store, all the things that you need. And the best part about this approach is that because you're leveraging the system browser, if you are already logged on to whatever you want to log on in your browser, then you will get single sign-on also into the native app, right? Because the session already exists in that browser. Yeah? So macOS has this special browser, Android has it, iOS has it, Windows doesn't, which is a bummer, right? Anyways. Okay, cool. So that's how that works. Yeah. And the last thing that I want to talk about is you probably maybe you heard or seen things like you are logged in via OAuth, right? And that's a lie. OAuth is not an authentication protocol. And you might now think, yeah, that's weird, right? Didn't we just see a login page and all of this? Yeah. Why is this not an authentication protocol? Now, think about it. Let's have a look again how the user-centric flow works, right? So we first open the front channel. We send the user to a login page. Yes, there is a login page, right? But this is not really the focus of OAuth. The focus of OAuth is getting tokens. Yeah? So you open that browser, it shows something, and then we get back an authorization code, right? The authorization code is just a random number. It doesn't tell us who the user is, right? And then you are opening the back channel and retrieve the access token. Is the client allowed to look into the access token to find out who the user is? No, he's not, right? So in other words, OAuth allows you to write an application that has access to someone's data, but strictly speaking, you don't know who that someone is, right? And you might say, oh, I don't care, as long as I have access to the data, and there are valid use cases for that. But very often you do care, right? You want to know who the user is in the application, and then you want to access data on behalf of that user. Yeah? And think about it. OAuth does not have a way to tell the server, like, show a login page, or in which language to show the login page, or maybe some usability things like pre-populate the username field, or whatever, right? This does not exist in OAuth because it wasn't the focus of OAuth. By the time when they created OAuth, there were existing authentication systems already, like SAML-based or whatever custom things. So yeah, this is not part of the OAuth spec. That's why there is another spec that sits on top of OAuth. It's called OpenID Connect. Okay, and OpenID Connect adds all of these missing features to OAuth to be able to do both user authentication and API access in a single round trip, right? And that is the sweet spot here, because 15 years ago, you did authentication with SAML, or maybe 10 years ago, and API access with OAuth. So you had to implement two protocols, and they didn't even really work together. And the nice thing about OpenID Connect is it basically sits on top of OAuth to give you both features in one protocol. And again, that means also you have less to learn. Yeah? So what does OpenID Connect add to OAuth? As I said, it adds a whole bunch of parameters that you can send to the authorization server to optimize the login experience, right? Things like, as I said, the language of the login page or other things that you might care about. Yeah? Also, it adds a new artifact here, which is coming back on the back channel, which is basically data about what happened at the authorization server. And that is exactly made for the client. Yeah? Remember, the client is not allowed to look at the access token, but this other token that is specifically made for the client to inspect it on the way back, right? And that is called the ID token, which is, I think, a really, really bad name because it's very confusing. Yeah, ID token, access token, refresh token, so many tokens, right? Which one do I use now for my API? Is it the ID token or is it the access token? Who cares? So think about the ID token. So when you hear the word ID token, in your brain, replace that string with authentication response. Okay? So ultimately here, we are making an authentication request to the server, and what we are getting back is an authentication response, right? And that is data that the server sends back to the client, so the client knows who is the user, for example, right? Here's the subject ID. What's the display name of the user? When did the user authenticate? How did the user authenticate? All of that data. And this now is not a private implementation detail between the issuer and the consumer. This is a standard. So you can take a dependency on the structure and format and semantics of that JSON object. Okay? So that's what OpenID Connect is in 7 minutes. Okay? It is really sitting on top of OAuth to make the authentication experience much better, and it allows you to do this very common task of authentication and API access in a single round trip. And with single round trip, I mean 2 round trips, of course, front channel and back channel, but logically a single round trip. Yeah? Okay, I think that's it. It took us only 53 minutes to explain OAuth. That's good. I'm getting better at this. So if you think that's interesting or it sparked your interest, you want to know more about it, as I said, don't read the OAuth 2.0 spec. It's not useful anymore 10 years after it's been written, in my opinion. Read the OAuth 2.1 spec. Yeah, it is exactly showing these 2 use cases that I just talked about. It has a whole bunch of really useful security guidance on top, which OAuth 2.0 didn't have by the time. Yeah, it's still in Korea, I think. But, you know, I think they have HTML versions these days, right, of these specs, yeah? Which is also nice. And then on top of that, have a look at OpenID Connect. Yeah? So if you care about these authentication scenarios, look at the OpenID Connect specification as well. I wrote a couple of blog posts that relate to this topic, yeah, that you can also read. And if you then want to really deep dive into the nitty-gritty details, here's the IETF page, and there's the OpenID Foundation page, which are the 2 standard bodies which you know, take care of these protocols. And there's a ton of reading material on there. Okay? So, any questions? Yes?
Excellent talk, Dominic.
Thank you.
You make it sound really easy. But I was wondering, do you think that PAR and RAR extensions will be part of your OAuth the good parts?
By the way, that's a troll question here, yeah? He's talking about additional standards, which are useful, right? But it's not for beginners, I think. But yeah, they will become useful in the future. Any other question that is not trolling me? Okay, then thanks for your time and enjoy the rest of the conference. Thank you.